Okay, we're looking at this chapter. We're talking about loan repayments. Okay, first thing we did was to create an amortization table. And effectively, if you can create an amortization table, you're probably going to do it on a computer because it's very tedious to do it by hand. But the fact of the matter is, with an amortization table, that gives you, at any point in time in the repayment of a loan, you will be able to tell how much you got paid on the loan, how much you owe on the loan, how much interest is accumulated. These are critical things for companies because companies need to know what their liabilities are. Retrospective method, I had to think then. The retrospective method, which effectively says, okay, the amount that is owed on a loan at a given time is a function of two things. It is a function of the future value of the original amount. So if you borrow $100,000, if you were to take that $100,000 and get the future value, but to the point that you're focused on. So you're saying, okay, let's find out what the value of the loan is 5 years into the loan, okay? So what we need to do is take that $100,000 forward 5 years. That's the first thing we need to do. So effectively, take the $100,000, find the future value of that $100,000 at the point that you're interested in looking at, that reference point. So what's the value of the loan in 5 years? We bring the $100,000 to ahead 5 years. Okay. The second part of that today, we're still looking at this, but we're going to talk about it from the point of view of mortgage. Mortgages is exactly the same. If we think about borrow $200,000 for a house, okay, you go borrow $200,000 for a house, and you did that, let's say 5 years ago, okay, arbitrarily. So you went and you borrowed $200,000 for a house 5 years ago. You've been making payments on it ever since. So you got this string of payments that you put on to pay down your mortgage. And you ask yourself, how much do I owe on my mortgage today? Right? So that's the natural question that you would ask. So in order to solve that, what you need to do is think about, okay, well, there was $200,000 borrowed 5 years ago. Let's bring that forward to today. So let's find the future value of the $200,000 that we borrowed on the mortgage, bring it to today, and that will give us an amount. Let's say it's $250,000. Again, I don't want to get into mechanicals, but let's say that that future value is $250,000 today. And then we say to ourselves, well, gee, we've been making payments of $500 a month or whatever it is for the last 5 years. That must be worth something too. Yeah. So what we do is we add up basically all of those string of payments, and we get the future value of that string of payments at year 5. So we know that we've taken the principal and we brought it up, and we know what the future value of that is on the day. We've taken the stream of payments and we brought that up. We know what that is on the day. We take the difference between what the value of the 250 minus the amount of payments, and that will give us how much we owe on the mortgage today. Simple. Easy peasy. Problem is with mortgages are, well, ordinary general annuities for any other name. Because what happens with mortgages is, according to Canadian law, mortgages tend to be compounded twice yearly. Okay, so there's 2 compounds a year, basically, with mortgages. That's the way the interest is calculated, which is neat. Okay, and we know, for the sake of this example, I'm not going to look at all the permutations of mortgages. There's lots of permutations, but let's assume that you're paying monthly. Okay, let's just keep it simple. We know that our payment is monthly. The compounding is twice yearly. The payment is monthly. And by definition, whenever our compounding and our payments are different, meaning they're not the same, it becomes an ordinary general annuity. And with this ordinary general annuity thing, we got to go through a little bit of a fooling around in order to calculate the value of I2, we call it, a revised version of interest, in order to calculate the payment, really. Okay. So what we're going to do today is look at this mortgage thing, and it's exactly the same thing we did the other day, but again, from the point of view of an ordinary general annuity. Here we are now. We're at this mortgage section, and we're going to do 3 basic things. We're going to calculate the mortgage payment. Now, we looked at it in the earlier version of when we did this before with payments, and that is how to calculate the payment. Okay, we should know that using the plain old present value formula, we can calculate the payment. Okay, and then we got to calculate the amount owing on the mortgage at any given point in time. So, I just talked about that, how we can do this kind of a system where we voila, we got ourselves the mortgage at any point in time. And we can calculate the accrued interest. We haven't talked about that yet, but we're going to talk about that. Okay. So as I said, a mortgage loan is different than a regular loan in law. It's no different any other way, okay? In law, the reason we call it a mortgage is a secured loan against real property. My wonderful house here, for example, that I'm looking around now, I have a mortgage on my house. So I've agreed to repay the bank. They borrowed me the money. They've lent me the money to go out and buy this house. And I've taken the money and paid for the house. Now I'm paying the loan back. Okay? There is a mortgage, a secured mortgage. If I stop paying my mortgage tomorrow, they're going to come and take my house. Simple as that. That's the way it works. So mortgages are paid off in 15 to 30 years. Mine is getting there. Knock on wood, I keep on paying big bucks on it. This period is known as the term of the mortgage. So you'll hear tell this term. Whenever you go to get a mortgage, the term on the mortgage is, and normally it is 25 years. That's the most common one. Because of the length of time involved in mortgages, they're renewed every 1 to 5 years. If you go to the bank and you look up, you'll see, or if you go to the website for the bank, I don't even have to physically go to the bank anymore, you will see there's a permutation of different types of mortgages that you can get. Okay, and the basic crux of it, though, is most mortgages are for about 25 years, and that it's renewed every year to 5 years. So there's at least five renewals that you do on your mortgage, and effectively that allows them to change the interest rates as it goes along. It's too much uncertainty over 25 years, so they say, look, most we'll lock in for is 5 years. So interest on mortgages normally compounded semi-annually. Okay, according to the federal law for banks, when they loan money, mortgages are compounded semi-annually. But mortgages, you can pay them, you can get mortgages that you pay weekly, bi-weekly, any number of combinations. So for the purposes of ourselves, we're going to look at it from a point of view of a monthly payment. Now we know, as I say, if the compounding period is different than the payment period, we're running into an ordinary general annuity. So if you recall, there's nothing new here. If you recall, whenever we get ordinary general annuity, we have to come up with a revised version of I, which is the interest rate. And we do that with a couple of calculations. The first one is this calculation. We got to calculate C, which is the number of compounds per year over the number of payments per year. Now, the good thing is, whenever you're talking about mortgages, is that C is usually a constant number, because the number of compounding periods is 2, as I just said. Most mortgages are compounded twice yearly, according to Canadian law. And the number of payments will assume 12. So, that's the common one. So that's 1 over 6, which is 0.16. So the value of C is often 0.16. You use that in order to calculate the version of I2, where I2 is 1 plus I to the power of C minus 1. And we've done lots and lots of examples using ordinary general annuities. So that should be something that's familiar there. And down below, you'll see there's the present value formula. Present value is the payment times 1 plus I2 to the minus n over I2. Now, so those are all the formulas, same formulas we've dealt with before. In order to calculate the amount owing, as I was just babbling on about there about 5 minutes ago, the amount owing on a mortgage loan is simply this simple formula, which is the balance at any point in time is really the future value of the amount borrowed to the reference point in time. So, let's assume we're 5.5 years into the mortgage. The reference point in time is 5.5 years. Okay. So we use that simple future value formula in order to calculate that. So we take whatever we borrowed, $200,000, and we take our I2 that we just calculated back there, and we throw it all in, and voila, we got ourselves the future value. And future value of the payments that you paid mortgage. So over the course of the last 5 years, you paid a string of payments of, say, $600 a month, 12. So you can do the calculation using that formula right there. Here's an example. Okay, here's an example. I'm only going to do the A part just to keep it simple here. So a $50,000 mortgage loan is written with a 20-year amortization period, 3-year term, and the interest rate is 4.5% compounded semi-annually. Payments are made monthly. Okay, so again, just to kind of differentiate this 20-year mortgage, 3-year term. To clarify, the mortgage is going to be paid off over the course of 20 years. However, it has to be renewed. The interest rate will change on it, or things will change on it in year 3. So the bank's going to come to you and say, let's talk about interest again. Let's change it up to whatever it is now. Maybe it'll be better. Maybe it'll be worse. We don't know. But effectively, that's when the interest rates change. Now, if we look at the question is asking us, what's the balance at the end of the 3 years? So we only have to worry about the fact that it's 4.5% compounded semi-annually, and for 3 years. So that should be telling you in your mind, okay, if I need to find the balance on that mortgage, the balance amount, I'm going to take the $50,000 and I'm going to bring it ahead 3 years. Okay, I'm going to bring the future value of $50,000 in 3 years' time, assuming a 4.5% compounded semi-annual rate. So that's the first calculation I got to do. The second calculation I got to do is, okay, I'm making payments on that mortgage, which I'm not sure what they are yet, but I'm making payments on that mortgage once monthly. So I'm going to take the string of payments that I've made on the mortgage for the past 3 years. I'm going to tally them up to get the future value of that string of payments. And I'm going to subtract the future value of the mortgage amount minus the future value of the string of payments, and that will give me the balance on the mortgage at that point in time. So let's get into the solution here. So before the balance is calculated, we must obtain the monthly payment. Okay, so the first thing we need to do is calculate the payment. Use the amortization period rather than determine a mortgage. Okay, we're only worried about 3 years. Calculate the monthly payment. That will repay the loan in 20 years, an interest rate of 4.5% compounded semi-annually. Mortgage payments constitute an ordinary general annuity. So our present value is $50,000. It's being paid off over 20 years. So that's 12 payments times 20 years, 240 is in. The interest rate, well, it says it's 4.5. So we got to cut that in half in order to get the semi-annual rate, which is 4.5 divided by 2. That's 2.25%. And then we got to calculate the C value. The C value is the number of compounds divided by the number of payments, which is 0.16. So that's where all those numbers come from. And then we're going to calculate the version of I2 as we move along. So the periodic interest rate that matches the 1 year payment interval is, and there's our calculation for I2. So 1 plus I, which is 1.0225, to the power of C, and we said that the value of C is 0.16 repeating. So you do the math on that, and that comes to 0.003715. So that's the I. So you got number one, $100,000 mortgage loan of 5.2% compounded semi-annually requires monthly payments based on a 25-year amortization. Assuming the interest rates do not change for the entire 25 years, complete the following table. Okay. Now, I don't want to do all of these, but I want to do a couple of them. Okay. So the very first thing, and I just want to walk through them. So the very first thing is we have a $100,000 mortgage. So the present value by definition is $100,000. The loan is at 5.2% compounded semiannually. So that's 5.2% compounded semiannually. Now we can calculate the I value of that by taking 5.2% dividing by 2, and that will come to 2.6% per compound, right? Which is 0.026. Then, well, seeing that it's a monthly payment and the compounding is semi-annual, we know that it's ordinary general annuity, so we're going to calculate the value of C. So to calculate the value of C, we got 2 over 12, which is 0.16. Repeating. And then we got to calculate the value of I, too. So we take the 0.26, which is 1 plus 0.26 to the power of C, and I calculate the value of C to be 0.16, and that will come at 0.0487. Okay, so just in terms of the calculation here, I've just got it shown up here now on the screen. So it's $100,000 is the amount of the loan. So that's the present value equals PMT bracket 1 minus 1.004, and 1.004 is the I2, to the power of 300, because it's, if you think about it, it is 25 years times 12. 25 times 12 would be 300. And that should come to 593.04. So I'm going back to the question. And the question says, okay, what is the balance at the end of the interval? So we want to be able to find out how much is the balance owing at the end of the interval, 5 years. Okay, the interval is 5 years. That's where that comes from right there. Okay. Fair enough. So what we need to be able to do is calculate the interval. Now, how do we do that? Well, let's go look at this slide here. Here is the basic formula, basic methodology, I'll call it. 2 formulas. So the balance at the end of the period, in this case 5 years, is the future value of the amount borrowed to the reference point in time. So that's 5 years, or in the case, this is 5 years at 12 payments a year, 60 payments, minus the future value of the stream of payments to the reference point. So we know the stream of payments is, each payment is 593.04, and there are 60 payments of 593.04. We just employ I2. So I just put up the calculation here. So to calculate the balance at the end of the 5 years, that's 60 payments. Okay, so we got to keep that in mind. So the balance after 60 payments is the future value of $100,000 after 60 payments. So you can see below the calculation there. Well, you borrowed $100,000. It's 1 plus the I2, and I2 is 0.00429 to the power of n. And well, we're talking 5 years at 12 payments a year, hence 60. So what we're doing is we're bringing that $100,000 forward ahead to 60 payments. At that point, it's worth $129,285.05. So essentially, that's like taking the whole lump of the loan, the whole amount of the loan, and bringing it, for comparison purposes, just bring it ahead. And if you bring it ahead for 5 years, it's worth $129,000. In other words, the amount if you didn't pay anything on your loan, let's assume that you paid nothing on your loan. At the end of 5 years, you'd end up having to pay $129,285.05. So if you didn't make any payments whatsoever, okay. So you got to subtract off all the payments you made, and all the payments you made is the second part of the calculation, where you take the future value of the 60 payments you've made. So you need to use the future value formula there. So the future value equals the payment, $593.04, times 1 plus I2, which is 1.00429, to the power of n, which is 60 minus 1, over I2, which is 0.00429. And if you did the math on that, that will come to $40,482.99. So what we're saying there is that the stream of payments that you've made of $593.04 over the 60 months, the value of that on the date of the 60th payment, the future value of it, the value of it is $40,482.99. Now, in order to calculate then the balance, you know that the sum total of the $100,000 brought ahead is $129,285. We know the sum total of the payments to that date is $40,000. Subtract one from the other, and you will get $88,802.05. Now, there's rounding, you know, don't worry about rounding. But the fact of the matter is, at the end of 5 years, you will still owe $88,802.05 on that mortgage.